Hi everyone, I'm Mingzhe Yang, a PhD student from the University of Tokyo. In our study, we investigate how fair AI can help people make unbiased decisions. Let's start with the motivation for this study. The purpose of our study is to guide humans to make fair decisions. Sometimes people judge others unfairly with bias. This bias causes social problems. Let me share a study that found gender bias in job applications. Researchers prepared two types of resumes. Both had the same skill, but different applicant names. Half of the names sounded white, and the other half were African American. When they submitted resumes for job application, resumes with white names were 1.5 times more likely to leading to the interview than those with African American names. To address the issue of bias in evaluating others, researchers have tried various approaches. For example, researchers conducted a large-scale survey in a company. First, they used a implicit association test to make employees aware of their gender biases. Then they held a lecture on how to address these biases. According to the surveys, after the lectures, the participants started to understand why gender equality is important. But in real-life situations like selecting mentors, there was no change in the number of women selected. This shows the difficulty of making unbiased evaluations, highlighting the need for more effective training in making fair evaluations. Making fair decisions is challenging for humans, but implementing fairness in machine learning models can be more straightforward. Considerable progress has been made in developing fair models through fairness-aware machine learning. This approach involves adjusting models trained on biased data to enable fair outcomes. We investigated the use of fair models as a teacher to show people how to make fair decisions. We call our method fair machine guidance. In fair machine guidance, we first train a model using fair awareness learning to estimate human evaluations. This model then used to guide users toward making fair decisions. No previous study has used fair models to guide evaluation like this. So our research question is, how does fair machine guidance impact human decision-making process? Now, let's look at how we implemented fair machine guidance. There are three steps. First, we corrected the human evaluations. Next, we trained a model with standard machine learning techniques using the fair evaluations. At the same time, we used fair awareness machine learning to train a fair model that addressed these biases. Then we used the both model to create teaching materials to help people make fairer decisions. In fair machine guidance, we are showing the teaching materials like here. We highlighted the attributes considered important in each model. For example, on the left side, the figure shows the user's criteria, while the right side, it shows the fair model's criteria. If the native country, Philippines, is marked in red on the left side, it indicated that there is a bias against these attributes in the evaluations. User can use these materials to identify which attributes they have biases against and learn how to make decisions more fairly aligned with the fair model. Now, let's talk about our experiment. We prepared two different conditions for our experiment. First one is called bias feedback, which is our baseline. We provided participants with an unfairness score as the teaching material. We defined the unfairness score as a difference in outcome of evaluation based on attributes. For example, the unfairness score illustrated the difference in how often you favored white people over non-white people in terms of race. The second one is called Fair Machine Guidance. We provided participants with not only the unfairness score, but also teaching material that highlighted the decision criteria. In our experiment, we set up two scenarios, predicting annual income and assessing credit risk. In each scenario, we presented, profiled, and asked participants to make their own evaluations. For example, in the income task, we asked participants to evaluate each person's annual income fairly, without racial bias, and then determine whether it was high or low. In the credit task, we asked participants to evaluate each person's credit risk without gender bias, and then determine whether it was high or low. We split our experiment into three phases. First, during the pretest phase, participants evaluate 100 people. From these evaluations, we only selected participants with a high unfairness score for the next phase. Next, the selected participant moved on to the treatment and mean test phase. In this phase, we trained personalized unfair and fair models for each participant and provided them with personalized teaching materials. After going through the treatment phase, participants completed a mean test. We repeated the treatment and mean test for 5 times. Finally, during the post-test phase, participants evaluate another 100 people, and we see how effective the treatment was. And the post-test, we surveyed the participants to understand more about their decision making and their perception of the treatment impact. Now, let me show you the result of the experiment. First, I will show you the effect of improving unfairness. This scatter plot shows the changes in unfairness from the pre-test to the post-test. Many participants in the bias feedback and fair machine guidance improved their unfairness. When it comes to improving unfairness, there was no significant difference between the bias feedback and the fair machine guidance. However, when we looked at the participant open-ended response, we noticed difference in the process of their evaluations. To analyze the process of participant evaluations, we relied on the mental correction process, outlines for necessary steps to eliminate human biases. First, people need to become aware of their biases. Second, the need to motivate to correct these biases. Third, they need to understand the direction and magnitude of their biases. And fourth, they know how to correct these biases. Based on this framework, we will show our result based on these latter three perspectives in order. First, let's examine the difference in motivated to correct biases. This figure shows the result from our Likert scale survey in which we asked, did this task make you reconsider the fairness? We found that fair machine guidance led participants to reconsider the fairness more effectively than bias feedback. Reacting to the comment that made them reconsider fairness, one participant shared, I felt that I had to revise the basis of my thinking. This showed that fair machine guidance really helped the participant reconsider about the fairness. On the other hand, regarding bias feedback, participant mentioned like, I was fair because I made a comprehensive decision. This indicates that they were not motivated to reconsider the fairness due to their own sense of fairness. Next, let's look at the difference in the terms of awareness of the magnitude and direction of bias. This figure shows the Likert scale responses to the question, did you think your decisions were fair? With fair machine guidance, participants reported lower fairness in their own judgment compared to the participant in the bias feedback. Participants in fair machine guidance were less confident about their fairness, probably because they become more aware of their biases. We heard comments such as, this was the opportunity to revise my preconceived notions. And I noticed a tendency to judge a person's ability to pay based on their occupation. These comments demonstrated that seeing their own criteria laid out helped participants recognize their biases. Finally, let's look at the difference in the terms of adjusting decision criteria. To assess the change in participant decision-making criteria, we analyzed the shift in their evaluation criteria from the pre-test to the post-test. We discovered that, thanks to the teaching material, fair machine guidance led to the significant change in decision-making criteria among participants compared to the bias feedback. Participants in the fair machine guidance shared it is important to evaluate people from a range of perspectives. This showed that some participants started to understand the value of considered multiple perspectives. Also, a participant mentioned, I was convinced and decided to follow the suggested criteria. This indicates that the teaching material led some participants to adjust their criteria. In the fair machine guidance, we visualized the fair model criteria, making it easier for many participants to identify which attributes they should consider changing. This helped many participants discover the new viewpoints and realize the value of the diverse perspective they had missed before. Also, many participants accepted AI advice during the fair machine guidance. Not all of them trusted it. However, they didn't immediately reject the AI advice. For instance, one participant said, I was not persuaded by the hint presented. This indicates that the lack of the trust in AI was the main reason some participants didn't follow the AI advice. However, comments such as, I felt I would eventually filter my decision based on how trustworthy it was. This shows that some participants reflected on the AI advice before dismissing it. Interestingly, even though who rejected the AI advice gained a new perspective on fairness through reflection on the teaching materials. Finally, here are the takeaways from our study. In AI-supported decision-making, it is important for AI developers to recognize that we don't need to make users fully trust in AI. Instead, we need to design AI systems that encourage users to think deeply about AI and to reflect on their own decisions. Moreover, it is important not only share the AI's outcomes, but also show the reasons behind evaluations. Thank you for your attention.